Greetings, folks. Joseph Kursky here with you, geographer and educator and proponent of using mapping tools. And here's another great example of maps in our everyday lives. Perseverance rover landed successfully on Mars, in large part because of accurate maps. So you can see this article from the International Cartographic Association, and the image that is there, the satellite image, shows the 8-kilometer, 5-mile landing ellipse diameter, the target location for the Perseverance inside the Jezero crater. For the navigation to work, the spacecraft needs the best possible maps of the terrain. And that's what my colleagues have done at the U.S. Geological Survey Astrogeology Facility in Flagstaff, Arizona. I worked at the USGS for 17 years and have very high regard for the work that those folks are doing. So you can see these articles and bring the relevance of maps to your classroom. Not only the satellite images, but the geologic map, which is right here that we're going to explore next. In the geologic maps, which is a scientific investigations map number 3464 from the U.S. Geological Survey, there's lots of things that you can look at on this map. You can look at fault lines, superficial geology, and much more. Wow, what a great map. This is one of the thematic maps that I was actually in the thematic mapping section of the USGS for many years, and again, some great years there, some great memories, and some great maps made. Great colleagues. But they continue to do the work there. We're going to zoom in on that landing ellipse, the targeted zone where it was deemed, again, based on maps and many hours of analysis, where the best location would be based on the mission of the Perseverance for the map, for the lander to actually land. Now, just like other geologic maps, you've got ages, you've got the description of the type of geology that's there, superficial, and then also under the surface. Obviously, unlike geologic maps of the Earth, we can't go up there and with a human being and take samples, but the other rovers have taken samples and analyzed those samples from the surface. There are much fewer sample points, of course, but despite that, it's notable that these astrogeologic and mapping GIS folks are able to map the surface in such fine detail. And not just of Mars, it's Ganymede and Callisto and the moon and so on. That's what these folks do. So when you think about the science behind mapping, cartography, geographic information systems, it is an amazing world that we're living in. And in another video, I'm going to help you explore how to examine the surface of Mars with a 2D and 3D web mapping application from my colleagues here at ESRI. So take a look at this map from the USGS and some of these reports that have come out, and talk to your students about the relevance of maps. Maps are not just on the Earth, and they're not just things on the surface. They're subsurface, and they're used in lots of different ways, including how to figure out how to land planetary missions and missions on other objects in the solar system and hopefully someday beyond. Thanks.